This is a recording for a presentation gave at MAST the 14th November 2008. So my presentation for the day is Pattern for Data-Centric Real-Time and Distributed Systems. So at Presentech, I am the Product Strategy and Marketing Manager for OpenSplice DDS, and in this slide you also see a picture of me, so at least you have a rough idea of how I look like. So the presentation today will go through DDS in brief, because perhaps there are some of you that are not necessarily very familiar with this technology and with this very cool standard. Then we'll go through some key architectural patterns, data modeling idioms, and then conclude. Since we have time constraint and there were lots of things I really wanted to talk, I've just picked up a subset of the patterns that I wanted to cover, but I will post a series of video at the URL that it's already included in the presentation. So if you're curious to learn more, please go and watch them online. But let's get started with what data distribution service for real-time system means and what it is. So it's an ultra-low latency real-time data-centric publish-subscribe technologies. It has been standardized so to be fully distributed, highly scalable, and highly available. So it's perhaps one of the few standards I know that requires implementation not to have a single point of failure. It has a policy-driven QoS configuration. So DDS has nearly 25 or between 20 and 30 QoS that allows you to tune all the parameters you might want about data distribution, data availability, bandwidth utilization, and so on. It supports dynamic discovery, which is a very important feature, full-time decoupling. A very rich technology ecosystem is also building up around this standard technology. And last but not least, it's an open standard. So it's an open standard which is fully standardized. And what do I mean with that? So compared with other technology, in DDS you have both a wire standard, which is very important when you want to make sure that two different implementation or two implementation of the standard coming from two different vendors are able to interoperate without losing performance, without losing QoS and so on. And it's also an API standard, which is very important when you want to be able to port application from implementation of a vendor, implementation of another vendor. More specifically, the wire protocol for DDS is called DDS-I, DDS Interoperability Wire Protocol, and the API standard is called DDS. And there are actually two macro layers in the API standard, one called Data-Centric Publish-Subscribe, that essentially supports, as we will see, data distribution on top of a relational data model. And then there is a data local reconstruction layer, which allows you essentially to do object relational mapping out of this relational data model. So this standard is relatively young. Well, it has 4 years and a half, but in this 4 years and a half, it has, I think, shown a pretty amazing adoption. And you can see that in terms of recommendation from administration. In these slides, we see that the US Navy has recommended it in the context of the open architecture. DISA and DISA have recommended it in the context of next generation net-centric system, and more specifically for tactical data dissemination. Eurocontrol has recently recommended it for exchange of flight data plan in air traffic control centers, pan-European. And finally, Kinetic has also recommended DDS for vehicular systems, reconfigurable vehicular systems. If we look in terms of adoptions, then even before relevant administration had recommended this technology, there were the most challenging projects in their domain, such as SOSCO or the European Flight Data Processor CoFlight, Zoomwalt or VTID, that had already decided to go with DDS, which I think is a very strong message. And this is just an extract of the many cool projects that are actually endorsing or already running on this technology. Okay, so now that we have seen very briefly what is DDS and who is recommending and who's using it, let's move to the architectural patterns. So one of the key and perhaps most important pattern that you need to grasp when you use DDS is the lingua franca, because this is really a key architectural approach that DDS enables. So let's try to understand first what is the problem. So the problem is that designing large-scale interoperable distributed system and system of system, it's a very complex engineering task, a very complex engineering endeavor. And the challenge lies in the fact that the techniques that we have used so far, be it functional decomposition or object-oriented decomposition, typically they work, yes, but then they lead to systems that are tightly coupled. And the challenge here lies in the fact that interfaces that are, or functions that are identified by functional object-oriented interface are inherently fragile because they tend to change over and over the lifetime of system. So the solution, and a solution that is really enabled by DDS and fully supported by DDS, is that of, instead of focusing on the functionality, focusing on the information model. So focusing on data and relationship that underlie your system. And we call this lingua franca, as you say in Latin, or you could call it Esperanto. The meaning is essentially the same. So in this case, once you identify the data and the relationship that is at the foundation of your system, so the fabric that will keep together your system, then your system becomes far more stable because this data is much more stable than functional interface. And once you agree on data, well, you can expand and add functionality at will without ever having to agree on a specific interface. And the known uses of this pattern are actually in DDS as well as in database management systems. Now let's try to understand how the lingua franca is really supported in DDS. So in DDS, the unit of information that can be exchanged between a publisher and a subscriber is called a topic. And a topic really is an association between a type, a unique name that identifies the topic, and a set of quality of service that define non-functional properties for this topic. As you see here, types are usually described in IDL, but also you can use XML. And once you define a topic, then you can actually define a key for this specific topic. And in this example, you see that I have a temperature sensor whose key is the TID, okay, which in this case is an integer. So you can think really of a topic as a database table in which rows represent instances, and every instance is has a different essentially key. And per row, if you consider the value that the rows has over time, you can see like a stream of samples, and in fact those are called DDS samples. So DDS provides also the ability of operating through topics by means of SQL, so you can run local queries as well as perform content-based subscription and so on. And this shouldn't surprise you, because if you really think of a topic as a database table, and you also realize, as I said a few slides ago, that there are no centralized server, no single point of failure, it sort of makes sense that you are able to run SQL query locally on the set of topics that you have subscribed. Now, the other powerful thing is that because DDS supports the concept of key, not only you can have instances, but you can use key to represent relationship in your data model. And later in this presentation, I will show you lots of idioms that show how you can be using keys very smartly. Then at runtime, you can navigate this relationship by using SQL92. And what you see in this slide is a very simple example that assumes that I'm trying to design a control system that regulates temperature in a building. And I'm showing that I have a floor which has several rooms, and on each room there are several conditioner as well as temperature sensor. And you see that the relationship, that these several one-to-many relationship, are all captured by playing with keys and foreign keys. Something else that you can do with DDS, okay, in its support for the lingua franca and its data centricity support, is that once you've defined your data model, your relational data model, you can actually create object views. And this is very powerful, because once you've agreed on a relational data model, that is your lingua franca, you can actually adapt this data model to a specific application by creating an object view that best matches the business logic of that application.